Now topic is covalent bond. Covalent bond. So covalent bond means, first of all, definition: the mutual sharing of electrons between two constituent atoms, two constituent or adjacent atoms is called covalent bond. The mutual sharing of electrons between two constituent atoms is called covalent bond. Generally, covalent bond formed between the non-metals. For example, hydrogen molecule, chlorine molecule, oxygen molecule, nitrogen molecule, ammonia, water, methane. These are all examples of covalent bond. Which type of bond present between the atoms means covalent bond. Now, first of all, hydrogen molecule. Covalent bond in hydrogen molecule. So hydrogen molecule contains two hydrogen atoms, hydrogen. Then its atomic number is 1 1. Then electronic configuration is 1s1 1s1. So these are the orbitals. So s orbital is only 1. Then electron is 1. So according to definition, sharing of electrons, mutual sharing of electrons between these two constituent atoms. These two are constituent atoms in a hydrogen molecule. So your first hydrogen gives 1 electron. So your second hydrogen gives 1 electron to get doublet. So doublet means stable, that is very near to helium configuration. Next one. So next, geometrical representation of hydrogen molecule. Two hydrogens are there, two hydrogen atoms. Then keep two hydrogens, symbols. Next one, hydrogen valence electron is, according to Lewis dot notation, we have to represent only valence electrons. Valence electrons means outermost shell electrons. So keep 1 dot. 1 dot means 1 electron. So for second hydrogen also keep 1 dot, 1 electron, 1 valence electron. Then so your for first hydrogen valence electron is 1 only. For second hydrogen valence electron is 1 only. So for first hydrogen, 1 more electron need to get a stable configuration of helium. So that's why hydrogen takes 1 electron from second hydrogen. Here also same. Second hydrogen takes 1 electron from first hydrogen to get stable. So your first hydrogen electrons are 2 only. Now second hydrogen electrons are 2. So both hydrogens are stable by the formation of H2 molecule. So simply this is H2 molecule. Now once again you see another method. So hydrogen valence electron is 1. Second hydrogen valence electron is 1 only. So first hydrogen shares 1 electron. Second hydrogen shares 1 electron. Then again you keep hydrogen. So electrons only, hydrogen 2 electrons. Then the mutual sharing of electrons between these two constituent atoms. So one bond formed between these two electrons. Generally one bond formed between the electrons. This is partial representation only. Next, H bond H. So here one electron, here one electron. One bond formed between these two electrons. Simply H2 molecule means H2. So how many bonds are present between two hydrogen atoms means single bond, one bond only. So that is covalent bond in hydrogen molecule. Next example is chlorine, Cl2 molecule. Now number of chlorine atoms in Cl2 molecule 2 only. Then chlorine atomic number is 17. Then electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p5. For second chlorine also same electronic configuration, 1s2, 2s2, 2p6, 3s2, 3p5. Next, so last orbital is p orbital in chlorine configuration. So p orbitals are 3, number of p orbitals are 3. So that's why you should draw 3 boxes. 3 boxes means 3 orbitals. So number of electrons in p orbital 5 only. So 1 2 3 4 5. So for second chlorine also 1 2 3 4 5 electrons. Then number of single electrons 2 only. So number of bonds depends upon single electrons only. So your single electron means then chlorine valence is 1 only. So for second chlorine also valence is 1 because of one unpaired electron is there in that electronic configuration. So your first chlorine gives 1 electron, second chlorine gives 1 electron to get doublet. Doublet means stable. And see chlorine, first chlorine valence electrons are 7, 2 plus 5 7 only. So keep 7 dots, 1 2 3 4 5 6 7. These are valence electrons of chlorine. Next for second chlorine 1 2 3 4 5 6 7. For second chlorine valence electrons also 7, outermost shell electrons 2 plus 5 7 only. Then first chlorine gives 1 electron, second chlorine gives 1 electron. Again you keep same dots, same electrons 2 3 4 5 6 7. So this is partial representation between the chlorine atoms, bond formation. Before the bond formation, this is partial representation only. Next one, bond formation. One bond formed between these two electrons. Then remaining electrons are called lone pair of electrons. Then geometrical representation. Chlorine. Chlorine valence electrons are 7 only. So that's why you should represent 7 valence electrons. So octet configuration means having 8 electrons in their outermost shell of an atom is called. So 7 electrons are there. So 1 electron means, so first chlorine taking one more electron from second chlorine. So in this circle number of total electrons are 8 only. 8 means stable. For second chlorine also 7 valence electrons are there. So that's why second chlorine takes 1 electron from first chlorine. So that's why in this circle total electrons are 7 plus 1, 8 only. 8 means stable. So now this Cl2 molecule, how many bonds are present between two chlorine atoms means single bond only. Next one, next example is O2, formation of O2. O2 molecule. So oxygen molecule contains 2 oxygen atoms. So oxygen atomic number is 8. For second oxygen atomic number is 8 only. Then electronic configuration is 1s2, 2s2, 2p4. For second oxygen also 1s2, 2s2, 2p4. Then last p orbital, so 3 3 only. So your electrons, so your energy level, orbital, electrons. So your p orbital having 4 electrons, 1 2 3 4. Next p orbitals, electrons are 4 only, 1 2 3 4. So your number of single electrons in first oxygen 1 2, in second oxygen number of single electrons 2 only. So that's why each oxygen bonding capacity is 2 only. Then valence electrons are 2 plus 4, 6 only. For second oxygen also valence electrons are 2 plus 4, 6 only. So that's why keep total valence electrons 1 2 3 4 5 6, just like pair you keep. Next second oxygen 1 2 3 4 5 6. So your first oxygen gives 1 electron, second oxygen gives 1 electron to get doublet. Next first oxygen gives another electron, second oxygen gives 1 more electron to get doublet. So that's why number of possible bonds between two oxygen atoms are 2 bonds only. Here 1 electron, here 1 electron. One bond formed between these 2 electrons, another bond formed between these 2 electrons. Now number of total possible bonds between two oxygen atoms, between these 2 constituent atoms are 2 bonds only. So your first oxygen shares 1 electron, second oxygen shares 1 more electron. So first oxygen shares 1 electron, second oxygen shares another electron. So 1 more. time you keep valence electrons. So this is a partial representation, bond formation. Next one is bond formation. 1 2 3 4. Remaining are lone pair of electrons. These are called lone pair. Lone pair means two electrons. Two electrons means one lone pair. So now number of total possible bonds are 2 only between these two oxygen atoms. Simply O2. So oxygen molecule is an example of multiple bond molecule. Next one, N2 molecule. Next example is N2 molecule. So here N2 molecule contains 2 nitrogen atoms. So atomic number is 7. Then nitrogen electronic configuration is 1s2, 2s2, 2p3 for second nitrogen. Electronic configuration is same only. Then last orbital, p orbitals. Then electrons 3 only, 1 2 3. So here also 3 electrons, 1 2 3. So first, according to definition, the mutual sharing of electrons between the two constituent atoms. Here 2 nitrogen atoms are constituent atoms. So first nitrogen gives 1 electron, second nitrogen gives 1 electron. Next one, first nitrogen second electron gives 1 electron. Next second nitrogen second electron. Next one, first nitrogen third electron. Next second nitrogen third electrons combines to form 3 bonds between 2 nitrogen atoms. Covalent bond formed between 2 non-metals. So nitrogen non-metal. So number of possible bonds between 2 nitrogen atoms are 3 only. Then keep nitrogen, first nitrogen. So first nitrogen valence electrons are last. Valence shell means last outermost shell electrons are 5. 2 plus 3. So that's why you keep 5 dots. 5 dots means 5 electrons. 5. So here bonds, one bond formed between first these 2 electrons. So that's why these 2 electrons. Next second bond formed between these 2 electrons. So these 2 electrons. Next third bond, these 2 electrons. Next one more time you keep same electrons. So this is partial representation. First bond to second bond to third bond. Next totally number of bonds 3. So here 1 lone pair. 2 electrons means 1 lone pair. 2 electrons means 1 lone pair. So oxygen molecule and nitrogen molecule. These two are examples of multiple covalent bond. Multi means more than one bond. Multiple covalent bond. So next one, methane. Covalent bond in methane. Methane formula is CH4. Then central atom is a carbon. Atomic number is 6. Then electronic configuration is 1s2, 2s2, 2p2 only. Next hydrogens are 4. 4 hydrogen atoms are there. 4 hydrogens. So 1 2 3 4 hydrogen atoms are there. Then atomic number is 1 1. Then electronic configuration is 1s1, 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 1s1. Then keep electron in a orbital. Next one is carbon p orbital. P orbitals are 3, number of p orbitals. Next electrons are 2 only. So electron is carbon ground state electronic configuration only. Then carbon excited state electronic configuration is 2s1, 2p3 only. 2p3 is excited state configuration. So that's why keep 1 electron. So if 1 electron shifts from s orbital to p orbital means that is called excited state. In carbon excited state, number of single electrons are 4. So here first carbon shares 1 electron, hydrogen shares 1 electron. To get doublet, hydrogen shares 1 electron, carbon shares 1 electron. So here carbon gives 1 electron, next hydrogen gives 1 electron. Next carbon last electron, hydrogen first electron. To get doublet only. So one bond formed between between the electrons, 2 electrons only. Now total possible bonds between carbon and hydrogen atoms 4 only. So carbon valence is 4, hydrogen valence is 1. Valence is nothing but binding capacity. So number of total bonds 1, 2, 3, 4 only. Then keep 4 valence electrons. Carbon valence electrons are 4 only. Then keep 4 valence electrons. Then hydrogens are 4. Then valence electrons are, valence electron is only 1. Hydrogen valence electron is only 1. One bond formed between 2 electrons. Sharing of electrons between these 2 atoms, carbon, hydrogen, carbon, hydrogen, carbon, hydrogen, carbon, hydrogen. So simply CH4 methane molecule. Then geometrical representation, geometrical diagram of methane molecule. So keep same dots, valence electrons you keep. Next to hydrogens, valence electron, hydrogens 4, valence electron 1 for hydrogen. So next, so carbon valence electrons are 4 only. So 8 electrons means stable. So 4 plus 4 means 8. So for carbon 4 electrons need to get octet configuration. So that's why carbon taking 4 electrons from 4 hydrogens. Then in this circle total number of electrons are 8 only. Here 4, here 4. Hydrogen electrons are 4, total 8. Then hydrogen taking 1 electron from carbon. So hydrogen will get helium configuration. So helium duplet configuration. Duplet also stable. Then taking 2 electrons. So this is the geometrical representation of methane molecule.